So this presentation is going to talk about cuckoo. How many of you here have heard of this before? Woo! Not bad. Well, we're going to walk through what cuckoo is, what it does, how to use it, and try to get into some details on how it works and some of its internals and so on. If you already use it or you've heard of it, it might be nothing particularly new. We're actually going to talk about maybe some new features that we haven't really released yet, but it's kind of an introductory talk on what it is. So some brief introduction. I'm Claudio. I'm a security researcher at Rapid7. I'm part of a bunch of non-profit organization. I created Cuckoo in the first place, and I founded malware.com. Then there's Mark here. Also work with me at Rapid7. Also part of Oninet. He also develops Cuckoo. And then here, last one is Julian. He has the shortest list of things. He's also a security researcher and is also developing on Cuckoo. And we are kind of the core team together with Alessandro, who is another core developer who is not here, unfortunately. But yeah, he co-developed Cuckoo almost from the beginning with me, and he also founded malware.com with me, and it also worked on other interesting projects like HostMap and SQL Map a little bit, and image forensics and so on. So basically what Cuckoo is a malware sandboxing application, which, I assume everybody here knows what that means, but just to do some introductions on why we actually built it and what it's generally being used for. So a malware analysis sandbox at least, is generally software or hardware appliances that receive some suspicious files or suspicious URLs and return some information about it. So return some details on their behavior or like what they do and how they change their system to what server it communicates and so on. Kind of gives an overview of the functionality of the file or of the URL being opened. So the reason why generally sandboxes are being used, it can be multiple reasons. Generally speaking, is if the user has a need to process high volumes of malware, or if he has to automate some specific tasks, or I don't know, if he has to integrate with some other defense solutions within a corporate network, or if he has to support some analysts that starts doing some forensics investigations and incident response and these kind of things, or also in my case, for instance, if you're too lazy to do reverse engineering. It has some pros and cons. So the pros, obviously, is that it can automate the whole process. That's kind of why you use them, right? You just feed something to it, it will just do something its own, and then at the end it will produce some results that might be usable or consumable in different ways. Generally speaking, they are able to process high volumes of malware. So I don't know if you're digesting some malware feeds from public services or from internal feeds or whatever, it allows you to collect some initial information, generic information of what the malware does, without digging into them specifically manually. And they're usable virtually by anyone in the sense that it simplifies a lot the process of trying to quickly understand what the malware is capable of. And obviously depend on the product and how the sandbox works, but it generally are able to give you a very quick understanding that are, don't really require strong binary math skills. You get the actual executed code, which is a pro and also a con in some situations. So a malware will just run in an isolated environment, most likely a virtual machine or a physical machine sometimes, and you will get what it would do under those specific circumstances. And it can be very effective if used smartly. So if it's integrated with other products, or if you're extract some indicators that you can later use to do some detection in your systems and so on, it can be applied in lots of different ways depending on what you're trying to achieve. The cons, it can be really expensive. So most sandboxes out there are actually commercial. I think when we started, it was one of the first, if not the first, real open source sandbox solution that reproduced most of the features of commercial solutions. So yeah, I mean, it's a good alternative if you don't have the financial capability to pay, I don't know, 100 to 200,000 euros per year. As I said, it might have the con of the fact that you're not actually seeing the full capabilities of the malware, because it will execute and it will see only what it executes. It might have some other portions of code which are not executed because maybe they're not triggered by some specific events, or I don't know, they're not being used under that specific platform, or other situations. And that could be a flaw, because you don't have the full understanding of what it could actually do on all different scenarios. The environment could be detected depending on how the sandbox is actually designed and built. If you use virtual machines, virtualization can be detected. If it instruments the casts, those instrumentation can be detected. So it can be a problem. And on the other side, if you're not using it smartly, it could be a complete waste of money and time, because if you're not consuming the results in a automated way, or if you're not really leveraging the maximum extent of the software, then it's kind of a waste of resources. So you guys jump in if need to do something. So having introduced what sandboxing is, Cuckoo Sandbox is a sandbox. So basically, yeah, it's an automated malware analysis system, which is, we designed it and we developed it with the mindset of making it as much easy to use and as much easy to customize as possible. It's released under GPL v3, so it's fully open source. All the different components are open source, and yeah, we are also being sponsored by Rapid7, who thankfully support our development efforts. So why do we build it? The first reason is because we strongly believe in open source. All of us are engaged in other development projects of open source projects. And one of the main reasons in the first place was that there was no real usable solution in the open source space for achieving this type of tasks. And consequently, it empowers students and independent researchers that don't really have the capability to buy expensive commercial solutions. And we also think that the way that it's actually designed, so being so open and flexible, it's a plus, because compared to commercial solutions, which are blind and you can't really change, modify them, or operate them very easily, it gives some additional features and some additional benefits. Some quick numbers: it has around 50,000 lines of code, sort of, mostly Python and C. We produce more than 2,000 commits, which is not really relevant because we commit one lines and things like that. We are 4 core developers, but there's a large amount of contributors that submit patches or regularly adds new functionalities. So is Thorsten here? Yeah. So he is one of our main contributors, actually. And it's relatively popular, I guess. I mean, in the last 6 months, we got around 15,000 downloads. So it's kind of an established project that's been running for almost 3 years. And it's still being actively developed. A bit of history: I started it in August 2010 as a GSOC project with the Oninet project, which is a no-profit organization. And since then, we released multiple versions. Hopefully, maybe we're actually going to hit the 1.0 next month. Nothing is guaranteed, though. So what do you need to know before we dig into it, and what do you need to do, generally speaking, to use it? Basic usage of Linux. We mostly develop it on Linux. It can also be used on Mac OS X, and some crazy people use it on Windows. But some basic understanding on how to set up things and so on. Some basic usage of knowledge on using virtual machines, so how to set up, how to configure virtualized networks and so on. In our setups, we mainly use VirtualBox, but we support also VMware and KVM and everything that is supported by libvirt. So there's different options for different virtualization software. And obviously need to know why you're using it and what you're going to do with it. So, mainly an understanding of how Windows works and what the different APIs do and what they represent in a malware, in a malicious execution. And so, yeah, also what type of malicious behaviors you could easily identify out of the analysis. And with Python, if you actually have some development background with Python, you can do some pretty interesting things due to the fact that it's so easily customized, and it's so, it has a pretty strong modular design that we're going to discuss a little bit later into details. So quickly, a brief overview of how it works. It's just a daemon that keeps running. when you submit something to it, it will pull a task, it will prepare the analysis, do the different configuration options, and then it will start off a virtual machine or a physical machine maybe in the future, and instrument the guest with some components that we wrote, and execute the malware inside the visualized environment, track what the malware does, and then save everything and process the results and produce some actual report. Ah, nice. So key features, almost everything, almost every single step within in the whole execution process is actually a module, so you can customize almost all different steps. It's completely automated, so you generally don't really need to interact with it too much. It can run concurrent analysis, so as many virtual machines you have available, it will be able to execute all of them at the same time. It's able to trace processes recursively, so if the malware injects another process or if it creates a child process and so on, we all try to follow these things at the best extent we can. You can customize the analysis process, so what actually happens inside a virtual machine. So you can say, okay, when I run the malware, I want to run Internet Explorer and open this URL or open these other things and do other magic stuff. You can create some signatures. We're going to talk about this later, but there is the possibility to isolate some particular events that are interested in being malicious behaviors or specific identifiers of malware families. So you can kind of create these behavioral signatures, let's say, and you can customize the processing and reporting of the results.
I just wanted to do a quick side story here because I think this is really important, and we cannot press this point enough. I mean, this is open source, so it's really not in terms of features, but the fact that it's open source sets it apart from some of the solutions that are out there, from some of the commercial solutions that you can buy, right? And this whole thing of designing it modular in a modular way and making it customizable, that is I think one of the main reasons why people actually like it and why people actually download it and use it. So as a side story, we know we've been told, someone walked up to us and said, yeah, we invested quite a lot of money in a commercial solution, and we run it, we like it, it has some better features than you guys have, but still, even though we spend 6-digit figures on this commercial solution, we run a small cluster of cuckoo on the side because it's so nicely customizable. So sometimes just the fact that it's open source gives people the ability to integrate it in a way that they maybe otherwise couldn't, or the company that they bought it from maybe doesn't have, or whatever. So there are people, for example, that for certain types of malware, they actually want to know, let's say, a configuration of that malware, and the configuration comes always in some kind of config file. So that's the case, for example, for the Zeus banking Trojan family. And if that comes with a certain configuration, and there's the actual stuff it needs to steal, there's the remote host that it needs to contact, and so on. So people use Cuckoo to actually run that and dump from memory with the customization they do at various stages. They automatically dump that information and take it out and use it for automatic processing on their side, which is maybe possible also with some commercial tools, but it might be more difficult. Maybe I mean, you can't look in the source. That's the whole point. So I can't press this enough. If you like to really leverage software to the most and just use this for a specific task, it can be really awesome. If you just think, hey, yeah, cool, malware, let's download it and run it, then it's not really going to benefit you much, right? I mean, with a specific goal, like with a certain project in mind, I think it can be really, really cool to have an open source project to do it compared to awesome features in commercial solutions.
Yeah, let's not make names. So briefly, how to install it. I mean, it's actually, everything is very well documented, and we have a whole guide on how to do everything step by step. But just to give you an overview, it used to be a huge pain in the ass to actually install it in the earlier versions, but now we're kind of simplifying the process to the best extent. So just install your virtualization software of choice. I recommend VirtualBox because it allows to do some interesting things on customizing the machine, but also other solutions are fine as well. Then you just download Cuckoo and extract it. You can just download it from the website, or we have a GitHub repository where you have both the latest stable version as well, the development branch, if you want to be brave and try it out. Install all the dependencies. Everything, again, is well documented. It's basically just a bunch of Python libraries that are used for different things. Create a virtual machine with Windows, possibly. Windows XP, Windows 7, everything should be working fine. We don't really support 64 bits for now, but for any other Windows version, 32 bits should be working. And then when you create it, you copy over a simple Python script that acts as an agent that allows the host machine and the virtual machine to communicate and exchange information and data, and then just run it, and then you snapshot the VM, and configure a couple of options to specify what is the name of the virtual machine, what is the IP address, and so on, and then you're ready to go and just launch it. So, want to cover usage? I should go on.
Yeah, so basically the usage of the tool, if you've launched it and it's running, it's not, it's just standing there and waiting, and basically looks, hey, can I find those machines that you told me that I would find, and then it keeps waiting. And to actually give malware to it to process and to analyze, you can use several ways. So for example, yeah, they're mostly in the utils folder in the actual project. And for example, there's just a submit.py, which is a command line possibility to add files for processing into the processing queue, into the internal database. So, you can run this submit.py with a bunch of parameters, but essentially you just give the path to the malware file, right? It could be a PDF, could be an exe. We support different file types, which I think we talk maybe a little bit later on or show. Yeah, there's also an API script, which basically starts a small API server, HTTP-based API, so that you can use this, for example, with some remote curl or whatever client that supports this API. So you can basically have it running on some server somewhere and don't need to run it on your local machine. Yeah, there's a small Django Web Interface. So first of all, we had right now in the utils path, there's this bottle web interface, which is a very small, very simple utility for having an upload thing on your browser, like an upload, what is it called, input field, where you can give a certain file, upload it, and then it gets added to the processing queue. We have a Django-based one that is a little bit more fancy, has a little bit nicer features in terms of specifying the options, but also viewing the results. That is actually in use on, as Claudio mentioned before, malware.com, which is kind of a public instance of Cuckoo running on some server that is actually sponsored to us. Yeah, and it's running, and you can use it just online if you want. If you want it on your own setup, this web interface that we use on malware.com is not yet right now available. We are planning to release it, but it's right now a little bit dodgy in some in some corners here and there. So we have a somewhat running demo with us on a small box here. I can show that later. But basically, there's going to be a better web interface also for it as well. In theory, as this is all Python open source, you can just use also Python to submit stuff. So if you have your own system, maybe you have like a spam collection system, and you want to add every file that you get as an attachment into it, you could just use a small Python script, and import this library, as you see, import the cuckoo database class, basically, instantiate it, add a file, and then you're good to go, and it should be processed automatically. Yeah. Let's go on.
So when you submit something, you can specify different options to every specific task that you're creating. You can specify an analysis package. We're going to explain what it actually is later on, but just quickly, is fundamentally a module that defines how the analysis will be conducted inside the virtualized environment. And you can also specify some options to this analysis package. If you have some customized module that you want to take some parameters to, you can pass it to the submission as well. You can specify a timeout, so for how long the analysis will run. If all the processes will terminate before the timeout, the analysis will be terminated. And if things really go wrong and a timeout is not hit, meaning that the virtual machine might be locked or otherwise compromised, there will be another watchdog timeout, which is configurable, that will just force the shutdown of the VM after a specific amount of seconds. You can even specify the machine, so on which machine specifically you want to run the analysis on. So if you have multiple machines, for instance, one with Windows XP, one with Windows 7, or with different software configurations, you can specify the identifier of the machine. Or you can specify the platform. This is kind of pointless right now because we only support Windows, but it's designed to be able to support also other platforms like Darwin or Linux, which hopefully will come in the future. You can also ask it to take a full memory dump of the virtual machine just before it gets shut down. So after the analysis is kind of completed, it will take a full memory dump, and will actually Thorsten here actually contributed some modules for Cuckoo that will be available in the next version that use leverage volatility API to do forensics on the memory dump. So it gives you an additional visibility on what happened inside the virtual machine. You can also specify to enforce the timeout. So, for instance, might be some cases where we're not actually able to follow the full, infection process. So you can just tell it, okay, no matter what, just execute it for this amount of time, even if all the processes that we see are terminated. And you can also specify a clock, so you can change the time inside the virtual machine. I think this was introduced because there was a bug or something, so we just added it. It could be fun. And when the analysis is completed, it will generate some results. Under the main directory, we'll create a folder which is named with the identifier of the analysis task. So if it's the number 1, number 2, number 3, it will have a specific directory, and it contains all the raw data, all the raw results, being actually show the slide afterwards. And then in this folder, there will be a subfolder containing the actual reports being generated. And that obviously depends. There's different modules, again, to regenerate the reports, and you can enable or disable which ones you want. The type of results that it generates, so it does trace of API calls. I will talk about it. Julian is going to talk about in details on how it actually does it. But basically, for each process that is being tracked, it will tell you all the API calls that we saw being called by the process. Yeah, we'll get into that later. It's also able to take file dumps. So if the malware process creates a file or deletes a file or change a file or something, it will take a copy of it so you can later on inspect it if needed. It takes screenshots of the whole execution, so of the desktop. It takes a pcap dump of the network traffic that it goes through. And you're also able to take specific process memory dumps. You just have to specify an options at submission, and it will take a dump of all the active processes that we're monitoring. And as I said, also whole system memory dump. So yeah, modules. We have lots of modules. They're basically divided between the core, so which is actually the host component, and the analyzer, which is the guest component that actually conduct the analysis inside the virtual machines. So in the core modules, we have 4 or 5 categories of modules. The first one is machinery modules. It's just basically Python classes that defines how Cuckoo can interact with the virtualization software. So how to start up the VM, how to stop it, how to revert a snapshot, how to, take the memory dump and things like that. We have some available by default, so VirtualBox, VMware, QEMU, and KVM, and all the others that are handled by libvirt, as I said before. They all somewhat work. Sometimes there might be some issues there we're still trying to fix. Sometimes happen that the virtualization software is not really expected to be running as many machines and shut them down, turn it on, and take snapshots and so on so regularly and so quickly. So sometimes it gets stuck. But we're working on it. So this is how the module would look like, very, very basically. This is the actual KVM module using libvirt. So generally speaking, actually this might be the wrong example, but all the modules are just Python classes that inherits a parent class, let's say, that already defines some basic structures and some basic operations that the module would do, and then you can customize it. In this case, if you're writing a machinery module for using libvirt, you can just import libvirt machinery class and then just specify the connection string, and it will just handle everything itself. In other cases, you might have to, specify how to use the command line utility of the virtualization software to do all the different start and stop operations. Yeah, and then we have auxiliary modules, which are going to be introduced in the next version, so they're not really available as of yet. There are, again, just Python classes, and these are just modules that can be used to run things concurrently to each analysis. So for instance, in the next version, we'll use it to do the network sniffing. So just run TCP dump concurrently to every specific analysis. And you can do it for doing other things. Run another utility that connects to the virtual machine and does something with it, or these kind of things that have to run concurrently from the host component. And yeah, this is the kind of thing. This is the abstract class that actually you have to inherit. It basically just consists of two functions, start and stop, and you do everything there. So before the analysis starts, it will run the auxiliary module, and then at the end it will stop it and do whatever it's supposed to be doing. We have processing modules. So after the analysis is completed, the results will be processed. So there's about a dozen different modules that do different things. And again, they're just Python classes. They take the raw results, whatever that result specifically is, and it does something with it. For instance, the main, let's say, component just takes all the API traces and then parse the raw file and trying to make more readable, output of the API calls trace. There's other modules that does some static analysis of the file, other modules that do, I don't know, network analysis of the pickup temp, and so on. And all these processing modules combined, after they're all executed, they produce a collection of a high-level results, let's say, that are then passed over to the next category, which will be the reporting module. So this is an example of another processing module. So another Python class just define, import a processing abstract class, and then there's a run function, and it do something with it. In this case, it will check if the analysis is a file, because we actually support both files and URL analysis. And if it's a file, it will open the binary being analyzed, and it will just dump all the strings of the binary. But yeah, just an example. And as I mentioned, we have signatures, also part of the core. So they can be used to specify and isolate specific patterns or specific things that you might be mostly interested in out of a malware execution. So if you, I don't know, run 10,000 malware per day, so you're not going to look at all 10,000 reports of all different malware. So you might have the need to extract just the most relevant ones because, I don't know, you're specifically interested in bank intrusions, or I don't know, you want to extract some configuration and things like that. So you can just scream out everything that is just interesting. So this is an example of a signature that just looks for mutexes being created by the malware process that might show that it's a spy Trojan. So it's very simple. Again, it's just a Python class inheriting the signature abstract class. There's some attributes to it defining the name of a signature, the description, the severity level, different categories, malware families, all these kind of things. And there's a run function that actually do the logic of the signature. In this case, as I said, just walk through all the different mutexes that are being created and see if someone matches the pattern. Another more complicated one, for instance, this is a signature that I created for Prinimalka, which is another banking Trojan. Prinimalka is particularly weird because it stores all its options in the Windows registry. So in theory, when the malware executes and stores this configuration in the registry, we will have some traces of it. So these signatures, for instance, just walk through all different processes that are being tracked during the analysis and see and try to identify whether these registry keys are being created or written to, and extract the value that are being added to the registry. And in this case, it just tries to extract the CNC server that the malware would contact to and update the description. So it can get a little bit more sophisticated and more complex eventually on how you generate these signatures. Most likely this will all change at some point because it's not really performant, but it's usable, let's say. And there's a community repository where people can share their signatures. Now there is about 30 or 40 or so, and you can just make a pull request, and I will merge it eventually. And there is a utility under the utils folder that you can use to download the signatures. So just launch it, specify ---- signatures, and it will download everything from the community repository. So you can use also what other people are using and interested in. And if you don't want one, you can skip it and so on. So yeah, sharing is caring. So if you create something interesting, make sure you share with the others. Finally, reporting modules. Basically, after the processing modules did something with the data, you want to make some use of it, right? So they're, again, just Python classes that take this collection of results being produced so far and generate something out of it. By default, we have a module for generating a JSON report, one that generates an HTML report, and one that generates a MIC report, which is some standard format, let's say XML format produced by Maitre, and the MongoDB report that just dumps the whole thing inside MongoDB. which is also what we use for the web interface that that Mark mentioned before. And this is what it would look like. So this is the actual JSON module. So again, just a Python class. In there, it's the abstract class, and then in the run function, do something with the results that are passed to it. So in this case, it just gets the whole thing and just store it as a JSON in a destination file. So yeah, analyzer modules. So these other category of modules that are run inside the virtual machine, so not on the host, so inside. We have two. The analysis packages are actually probably the most important part of the whole thing, because these are modules that define how cuckoo, how the component inside the virtual machine will actually execute the malware and what it's going to do within the virtual machine. So you can use it for scripting different tasks. For instance, Mark mentioned before that some people are using it to dump, the configuration file of banking trojans from the process memory and so on. But you can do pretty much everything that is scriptable with Python inside the virtual machine. So there's different uses of it. This is an example of the basic analysis package for Windows executables. It has some different options that can be specified at submission. The free option will basically just run the malware without tracing the API calls. Sometimes it's needed, for instance, if the malware is able to detect our instrumentation, you can just run it, and I don't know, if you're interested in network traffic that you wouldn't get otherwise. You can get arguments that you can pass to the malware. For instance, if, I don't know, it expects some parameters to the execution, you can specify those as well. And then you create the process and create it suspended, and then inject into it some DLL that Julian is going to explain in a bit, and then resume it. And when analysis is finished, if the option is enabled, it can take a dump of the process memory. The check function is a function that is run every second. So if you're, I don't know, looking for a specific event to happen inside the virtual machine, you can put a logic, block in here. And for instance, if a specific file is being created and you're just interested to that point and you return false, then the analysis will terminate because it believes that the condition is being matched. And the last one is auxiliary modules again, so also called auxiliary, but within the virtual machine, not on the host. Again, Python modules, and they're a thing that are run in the same way concurrently to the analysis, but on the virtual machine. So by default, we have two modules, one that just takes screenshots of the desktop, and one that tries to emulate human interaction. And we did this because there's some, we encountered some malware, for instance, that just start off the main routines only if it sees a mouse moving, or if it detects a mouse click or things like that. So these modules is actually trying to do these things, moving mouse around and clicking things, and it's also able to click through dialog windows eventually if you recognize a button, like if it contains OK or next or install or these things, they will try to click these things automatically. And yeah, this is how this is not how it looks like. There's a whole bunch of lines that are not printed here, but you can see basically it's just another Python class that just have a run function that does something. And in this case, just move the mouse, click the mouse, and then sleep for 1 second and move on. So now, yeah.
Okay, so Claudio has been talking for quite some while. I'll be talking a bit about the internals. As explained, cuckoo starts a virtual machine, and inside the virtual machine it spawns a process, which is the malware or the sample or the PDF file, and we inject the DLL into this process. And basically what we try to do is inline hooking. So there's a bunch of APIs, a bunch of Windows functions in which we are interested, and we hook these functions. So when the malware or the PDF from Adobe, when it calls these API functions, we intercept this, and we lock their parameters. So if, for example, a file is created, then the create file API is called, and we log this, and we see the file name, and then we can say, okay, this file is interesting to us, we want to dump it eventually. So we keep track of this file, etc., etc. So with the analyzer package, in the code you see here, a new process is created, and the process is created suspended, like Claudio told us before. And when it's suspended, it does not actually run the process yet, but it allows us to inject our DLL, and then we resume the process. By doing this, we get the ability to run our DLL code before the actual binary is run, and so we can place our hooks. And then we have control over the process to some extent. Okay, and this is the child injection. So we hook a API called create process, and the create process function, it creates a new process, like the function name says. So whenever a child, whenever a sample creates a new process, for example, you have the run PE method, which is used by a lot of malware to decrypt their malware runtime and inject it into another process. When this happens, we intercept the create process function and we inject our DLL. And basically, before the execution returns to the malware, we want to have injected our DLL. And we do this by using APC, which is asynchronous procedure call. And basically, we again create a new process in suspended method. We inject our DLL and then we resume it afterwards. And this allows us again to run our DLL code before the new process is spawned, and we can again set our hooks and we control the process again. So malware tries to evade sandboxes or hooks in general. So what it does, it injects into explorer.exe, for example. And when it does this, we are also interested in the injection. So when the malware injects into Internet Explorer, then we also inject in there, just like we inject into child processes. And in the child, we again hook the APIs. And by hooking all the processes recursively, we have a full API log of all the APIs that are being called by the malware. So we get a full trace of everything it tries to do. And then in the end, we can do the results and the reporting, etc. And we can do our analysis on the created logs. So we hook about 170 APIs. And we try to hook as low as possible. So there's various versions for a lot of functions in Windows. So you have the ASCII version, which is normal English text. And then you have the Unicode versions, which is, for example, the same function, but it allows you to send like Chinese text, etc. So we hook the lowest possible. And through that, we try to intercept all the interesting API calls. And we also hook some higher level functions such as shell execute and system. It's basically a wraparound create process, and it gives you more information. And in the end, we get a report with all the interesting API calls, and not with a lot of garbage usually. Would you like to do this? Okay.
No. So basically, we're going to quickly stop here. I'm going to show you a small demo because we're almost out of time. So I guess the anti sandbox stuff we can maybe skip over very quickly if I can manage to do the demo quickly. But yeah, I mean, the basic point is, as you saw, we use a little bit an old technique right now, but yeah, just DLL injection to processes and then do inline hooking of functions. So it proves very effective still nowadays. Of course, it's not capturing everything. I mean, we can be defeated, as can probably any other technology to do this. But this is what we use, and I think it's still quite cool. And yeah, basically, you know, during an analysis run, you know, the malware injects here, starts a cmd.exe to execute some batch file. It does, you know, several things, and we kind of try to keep track of all those processes and you know, follow the whole execution. And when it all stops, we stop the analysis, or when the timeout is hit, we stop the analysis. So it's kind of all configurable and really depends on what malware you're looking at and what you see, what you want to see in the end. So again, it's more like a framework than really a ready-made complete package. But it works in this way. So let's see a small demo here. So what I'm going to do is I'll quickly run cuckoo, and it's already configured, everything's set up, right? So it will just wait there and say, yeah, I saw the machine, and it's waiting there for tasks. Then I'm going to submit a malware sample, which is the almost everyone knows this, the evil calculator.exe. And yeah, it will upload it to the machine, start it up, you know, do some analysis, and we can quickly look into the report. And then I'm also just quickly showing you one report, how it looks like in this advanced web interface that I talked about, right? This Django one. So I'm just showing you the malware.com interface. And then maybe if we have like 5 minutes more, we could maybe introduce a little bit of, you know, the arms race that we have to fight every day. All right, let me quickly set this up. All right, so yeah, I'm here in my cuckoo clean.jet, which is just a clean checkout. Basically, has some configuration in it, but my development one is a little bit messed up as currently I'm testing some new features and so on. So yeah, this is basically a clean setup, just the configuration done and so on. So what you see is nice ASCII art, always the most important thing in open source tools, right? So if we start it again, that would be a different one. That's the most important feature. No, really though, this is started up with the debug mode. So this will give you a little bit more information just for, you know, for this demonstration purpose. We will see how basically the analysis uploads results and screenshots and so on to the host. So here we see it's importing modules, and let's see, it's importing modules. For example, you can see the different types of categories here and what is installed. So there's one signature, creates exe. There are the processing modules that are default, and so on. So we only need the VirtualBox machinery module here because I'm using VirtualBox, and it's loaded one machine, and it's waiting for the analysis task. Right. So now let's submit the evil calculator. Submit, there it is. So temp calc.exe, the normal Windows calculator, and we specify a timeout of 30 so that it's a little bit faster for the sake of this demonstration. Hopefully, this should start up. On the left, it gives you some output. We'll go over it afterwards, just so that you can see quickly the outline, kind of. So the virtual machine is started in the bottom right, and now it should connect to it and upload the calculator, the malware binary into it, start it up, and it's right now analyzing the stuff, right? We'll look at the output afterwards, just so you see how this generally happens. This, of course, looks a little bit interactive, but you can actually use, instead of like the full VirtualBox window, you can just do it headless without displaying it, right? Because if you run Cuckoo on a server, you don't really have the display to show that stuff, and you don't really want to either. Just for the demonstration. Okay, so we're almost at 30 seconds, I hope, and it should shut it down and do the processing. All right, there it goes. It's gone. Does some processing, and then it's finished, and we can quickly look into the output, which is going to be completely messed up now, of course. Yeah, I can just open the log file. That's correct. Okay, give me a sec. Yeah, this is actually the inside of the machine log. So this would be normally the outside machine log. Sadly, I did lower the size of the window, so this is a little bit messed up here. Can I report? Oh, you mean the cuckoo log? Yeah. So basically, we have two logs. One is the outside log, and one is the inside log of the analyzer. So in the outside log, you will see down here. Yeah, let's do it this way, right? So we don't have the nice syntax highlighting here, the nice colors, but anyway, in the top somewhere, where do we have it? There we have it. So I submitted the task. It has acquired the machine. It's starting the sniffer in the bottom. Then you see stopped auxiliary motor sniffer. What's that? I probably, no. That's weird. Okay, that shouldn't happen. But basically, it started the VM, and then uploads the sample to it. We can go further down because, yeah. So there it starts the analysis on the guest. You see the IP. Wait a second. Wait a second. Where are we? Okay, and here you see some, for example, some of the debug messages that I talked about. So you see there's a new connection from the VM, and it says here that it has the log handler for live analysis log initialized. So basically, in real time, we get the analyzer log from the part inside the machine to the outside. Then we also get some screenshots here. You can see an file upload request of shots001.jpg and so on. We can quickly maybe look.
Yeah, the reason why we actually did this, so now it's able to log stuff in real time, which is kind of new feature since the last version. It's for two reasons. The first one is that lots of malware that we analyzed completely fucked up the VM. And previously we used to store the results on the VM itself and then dump it after the analysis was finished. and that proved to be unsuccessful, because if the VMs is compromised and unusable, we cannot get the results anymore. So now it's able to log all the results in real time, so we still have a trace even if the VM is compromised. And also because at some point some malware come up and generating 3-4 gigabyte of logs, and sending them through XML RPC is not exactly the best idea. So now we're streaming everything in real time, which is much better.
Yeah, so just quickly here, it generates the reporting modules, as Claudio talked about before. There's a JSON report here. I'm showing you the HTML one. So, just a bunch of stats, a little bit of file details. Then the screenshots, you can, click them and make them bigger and so on. And, oh, this was a bad idea. Let's go back. All right. So then you have some static analysis, like version infos, sections of the file. Not really important right now, but in the bottom, we should see the actual behavior log, basically. Of course, on the small screen size, a little bit hard to view, but basically you see, okay, there's a DLL loaded. It calls is debugger present. It calls, for example, get system metrics here, open sections, and so on. So you basically see all the API calls. And this is important because, as Claudio mentioned earlier, to leverage this technology, right, to leverage Cuckoo Sandbox, you kind of need a little bit of an understanding of what this means. Because if you don't know, if you're not looking for anything, but you're just scrolling through it, you at least need a little bit of understanding about what Windows API calls are, which ones are doing what, and so on. If you're looking just for specific behavior, then also search only for that specific behavior, right? I mean, if you're looking for a certain file being opened, just look for open file or create file, for example, or look into the summary that we had up there. Another possibility would be to create a signature specific for your goals and for what you want to find, and just have basically the signature output on top. Quickly before we close here, malware.com, as I said, is the kind of our public version, public interface hosted on a big ass server that is donated. And you can just go to that domain and use Cuckoo Online before setting up yourself. And basically, as long as the people that upload any files there, the analysis is shared with anyone. So you can just click other analysis from other people, but you can also, of course, upload your own files and look at it. So the interface here looks a little bit different than the HTML report that I showed, because it is an actual interactive interface where you can actually comment and tag and stuff like that. But you can also look a little bit more, let's say, it's a little bit more fancy to that extent. And this web interface we actually will release also as open source so that you can use it together with your offline Cuckoo version at home, because the HTML reports are nice, but this web interface is better. So yeah, Claudio is just browsing a little bit through it. Feel free to go to the website and check it out yourself because we're running out of time. Yeah, Claudio, do you want to close?
Just looking at this randomly, and it's interesting. It's called briankrebs.exe. I don't know if you guys know him, but it's a pretty popular journalist in security. And it connects to rc.troll.tv and seems to be some RC botnet or something. So I mean, this is basically the same interface that you will find soon, hopefully on publicly open source, as soon as we fix some nasty bugs. And this is a little bit extended, so there's malware.com also have some registration capabilities, so you can register an account. And if you register, you have different functionality available. For instance, you can download the file, you can download the pickups, and all that stuff. There is even, if you're logged in, there is a search interface where you can search for specific behavioral events or hashes or all that stuff. But most of these things will be available, as Mark said, plus some other things like the volatility analysis that is not present in malware.com. But it pretty much will look like this, which is much more usable and fancy as well than the original HTML report. 7. All right. How do I full screen? What? So let's skip through this. Blah 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 blah. Yeah, I mean, these were just some interesting facts that we just worked on over the time on tricks that we needed to introduce to circumvent some, detection mechanism that malware started using for different things. There is some sleep trick that would just wait for a little bit of time so that the execution would just run out, and we skip the sleeps in the first seconds and all these kind of things. Anti-mouse monitor, we talked about it. Anti-virtualization, it's kind of a big complex thing, but there's some things you can do to it. I think we'll put these slides online, so there's all references that you can use, and other things you can change. Conclusions. So summing up, it's an open source solution, so everything is open, everything is available on GitHub. It will remain so. We don't really have any plan to close it down or anything. It's pretty flexible and customizable, as you saw so far. It's very easy to integrate with lots of different things. Obviously, it's kind of up to your own environment and what kind of things you're trying to achieve. It's very actively developed. Sort of. I mean, we try to invest as much time as we can. Obviously, it's not our day job, so it's still, doing some progress constantly. Feature things, improved performances. We have some issues currently on how we process some of the results that we are actually working on right now. If the results are big or if you have lots of signatures, it might be a little bit slow to actually go through the whole thing. So we're working on improving this part. We're working on bare metal support, so be able to analyze things on physical machines. It's actually already available. We're still not sure about some of the details on how it works, but some guys from i3 actually contributed some modules to be able to run malware on physical system and keep reimaging the system after the analysis, which is a bit painful, but it works. Hopefully add Linux and Mac OS X support, but I mean there's no really big effort going into this direction. But if you're an expert in those platforms, it would be really great if you could contribute. And any feedback is more than welcome, because we keep changing and improving new things as soon as people talk to us and say, okay, I need this thing, I need this, that, and it's not available yet. Other stuff, yeah, malware.com, public available, you saw so far. With VxCage, another tool that I developed for storing binary files like malware, because I keep losing them all the time. Questions? Do you have a microphone for the people with the questions, or? Thank you. So basically the question was, since this cuckoo basically, specifically malware.com, if I understood correctly, connects directly to the target service, it doesn't really contain the network connections, if it can be abused in different ways. I'm not sure exactly what you mean. I mean, the biggest concern that we have in these cases, especially for public setups, is for instance, if the malware, sends spam emails, like tons of spam emails through our web servers, through our servers, and then we look like being, spammers. And actually happened in the past, so we also got blacklisted by Spamhaus at some point. But we had some countermeasure for that. Natively in Cuckoo itself, in the project, in the tool itself, there's nothing. There's no real feature to contain these things. We kind of leave it up to the user to decide how it has to contain the network traffic and what can go out and what cannot. It's kind of up to them.
Yeah, just really quick. So I personally, when I run Cuckoo, I run it completely contained. So I never let it go out to the network, and I provide some fake services. So I redirect all DNS requests to my own, IP locally. I provide some fake services. So if I do it on my laptop, I never let it contact to the internet. On this particular setup, like on malware.com, we don't really care. I mean, it's a sponsored system. They said it's okay if the malware, connects to IRC or whatever. So yeah, we just let it get out, right? We have some stuff in place. So for example, SMTP is a little bit limited. I think we might redirect it actually. But for example, there's a IP tables rule in place for like limiting connection per time, so we don't DDoS other people with that system and so on. So but that is out of the scope of the project. So you kind of do that with your setup and with your firewall of that specific system where you run it on, but it's not really a feature in Cuckoo itself. So we provide some scripts and everything that you could use for it, but it's not part of the project itself. Yeah, definitely. Yeah, please.
So the question is, can you also run Cuckoo, the network, through a proxy? A friend of ours is actually working on a library to run next to Cuckoo, or maybe even integrate it. And you can simulate like IRC servers and web requests. And you can probably set rules like I want to allow Google, but I don't want to allow this botnet URL, etc. So you can customize it.
Yeah, I mean, the question was if you can actually tunnel the whole traffic that Cuckoo generates through a proxy. I mean, yeah, you can do it. For instance, we do it in our private setup. So we have our own SOX proxy that just tunnel the whole thing through that. And we have different IPs available that we use to tunnel things out and move things forward. Yeah, I mean, you can do it. I mean, it's up to your own configuration. I mean, everything that comes out of the network interface, it's up to you on how to configure. Yeah, not natively. Yeah, that could be some kind of idea. But yeah, it happened in the past. Actually, some people profiling our systems and publishing the details online, and you know, I don't know exactly for what reason. But I mean, yeah, you can totally do it. And getting back to the other question previously, we also we do, for instance, in our setup, everything is configured outside of Cuckoo itself. But we have, for instance, an SMTP, you know, Dropbox, let's say. So we have postfix running. We intercept all spam messages that go out, so we don't really spam anyone. We have some targeting, so we don't really DDoS anyone. And you know, the execution is actually contained for just few seconds, so it's kind of okay. We never got too many complaints lately, so it's all right.
Yeah, guys, we have to finish. If you have questions, hit us outside. We need to make room for Dimitri, but stay for his presentation because it's awesome. So yeah, Cuckoo runs also on small boxes. If you want to check them out, you can come out afterwards. We'll also be around in the Hack Center tomorrow.